few episodes ago, we created this. This was our two-dimensional rocker bell crank for our all-wheel drive 1959 El Camino. If you guys remember, we took our input and our output and it created this system so we can drive our coilover at a different angle. I put a ton of time into this, put a ton of love, and I even created a model. Weeks and weeks of playing with this, I came up with this design. Now we're at a very crucial point. We're gonna create this out of 6061 aluminum. So we're gonna take this, bring it to a pro, and he's gonna whittle this out of this chunk of aluminum. So this is huge and monumental for me because this is the first billet part for the Elco. And yeah, I just really wanna see this design come to life and I'm excited to show it with you guys. We're gonna get super techie with it. We're gonna get a little wild to show you all the information this guy has in his brain, how to get there. So let's take the design, let's get rocking and rolling. Now this is very exciting for me. This is actually the first billet part that I'm creating for the all-wheel drive El Camino. Now I'm no machinist, so what do you do when you're not one? You find one, you love them, you latch on, and I want to introduce you to my mentor, Jamie Marzilli. He's one of the wildest men that I know. He's actually going to show you the process from start to finish of how we take this design and actually machine it out of the 6061. Hopefully we learn something. How you doing, sir?
Hey, Don, how are you?
So this is the legend himself. He is the gentleman who started all this with his wife, and I was just telling him how impressed I am. This place is an absolute mecca.
Well, thank you, Don.
I just came in here and intruded on you.
I appreciate having you here.
Inspiring to know that you can create anything really here.
Can. If you can imagine it, we can cut it.
I can design this stuff. When it comes to machining, it's going to be fun to see if my design can actually be machined. I don't design it thinking it looks good. Can it really be comprehended and actually turn into something?
Well, that's actually a huge problem in the industry right now, which is a lot of young engineers, a lot of the tribal knowledge is kind of retired. And so here at Marzilli Machine, we do a lot of what's called DFM, design for manufacturing. And so a gentleman like you will come, bring us a design, bring us a raw idea, and what we'll do is we'll teach you ways to reduce the cost on it to improve the efficiency of the machining process. That way we can get the parts made and get them out on time and at a budget that you can afford.
I'm super excited to take this, and now that I know I'm in a pro's hands, I would love to learn 5% of what you got in that brain of yours, and hopefully we could transfer over some of these guys and they learn too. And just see the process. Like, I really have not gone start to finish in the whole machining process. It'll be kind of cool to see what I blundered on, how you do it, and then really taking that design and transferring over.
Well, we'll pull the curtain back, and we got a saying here that pour a gallon into a shot glass, Don, and you get to keep the shot glass.
My man. Let's do it.
Since you didn't bring any blueprints, we're going to work together to do some of the engineering that needs to be done to make sure all the components will fit together.
Yep.
But really what we're going to do is sit down together and have a war room meeting where we're going to talk about the process and what's important to you, how you want it to go, how we're going to flow it through the company. This is something we would normally do if we got a purchase order from a regular customer. By planning and making sure that we know our plan of attack, we can make sure that we can reduce any errors that we might run into down the road.
Is there anything that I could have done to this design to screw you up?
Yeah, you could have paid a professional to do it. Let's get the model up and we can review some of the things that, some of the gotchas that could happen during the manufacturing process.
So this is the bell crank rocker for the El Camino, right? So what we have is, I really just put my coilovers in a different spot and it helps me translate the input load, but it's just an arm. It's like the rocker of an engine. I have all the input. I made the sizing what I thought this should be. It might be a little overbuilt, but really the input comes from the lower control arm, and then this drive force comes into the coilover, helps it collapse, and helps me put the coilover, like an F1 car. It helps me translate it at a different angle.
What about hardware? Did you make any allowances for hardware and for the fit of the hardware and how it's going to go together?
These are perfect. The bull hole spacing is perfect, and theoretically the inlet for my coilover mount and the coilover itself is all correct. What I'm going to do is right here, there's going to be two tabs that are 1/4 inch. I'm going to box into the frame, and it's going to sandwich over it, and this thing's going to pop in with a bolt. And that's where it pivots. So this is where all the load's going to be. It's going to be trying to rip off from this, so we need some sort of a bearing surface.
This is the pivot point?
Yes, sir, yeah.
Okay, so then we're definitely going to want to install some bearings in here.
Yeah.
So what I'll do is I'm going to load this into my CAD software, and we're going to cut some holes, extruding through the solid to make room for the size bearings that you want to put in here. We'll add some snap ring grooves. We'll leave some room for the aluminum spacers that are going to come in on the side.
Yep.
And then what we can do is we can actually mock it up and make sure that everything is gonna fit before we start cutting it. Because this hasn't been designed for manufacturing, there's gonna be a little bit here where what I'm gonna ask you to do is to just trust my judgment. And so when I'm programming it and I see the limitations that we're gonna have in our tool paths, I'm just gonna do what I think is best in the moment, on the spot, make it look good, make it functional. So this way you don't have to go back to the drawing board, kind of get these fillets to work out perfectly. The machine itself and the tooling we're gonna use is gonna have its limitations. And so we're just gonna go to the max that we can do in the machine.
Machining wise, even if I messed up, let's say if I did something that was strange in here that you can't get to, you'll be able to change it in the code is what you're saying?
Well, I'm gonna change it by how I'm gonna attach my tool path. So for example, in here, you have a little cusp in a negative, right? And so that would be very expensive and very difficult to get into with very small tooling. And so since I know what this thing does, and we actually wanna bring it more strength into this corner, I'm actually just gonna come in and just machine that out nice and smooth and round so it matches this side.
Okay.
So that's an example of what I mean.
All right, so I was a little worried about that because it wasn't like super dialed. I went nuts. When I designed the original piece, I just kind of made it look artistic. My plot points are perfect. I put a lot of time into making sure this and the ratio is all there. And then I just widened it up to fill all my pockets in for my coilover. And then from there, I just went kind of nuts with the shape. So I was a little worried that this might have been a little too Star Trek.
I love Star Trek.
Yeah?
Yeah, I'm a big Trekkie. Have been for a long time.
This actually reminded me of something that I saw in one of the episodes. It was like a bracket that they held to help for the roof. It was like this really weird triangular like overhung piece. I was like, yeah, that's where I got it from.
And you said, I want to stick that in my car.
That's it.
Okay.
This is gonna be the first build piece for the Elko.
The first of many.
Yes. Let's do it. All right, buddy.
This machine allows us to machine 5 axes of space. So a cube has 6 axes, 6 sides to it. This allows us to machine 5 out of the 6 sides, the 6th side being the one that we're holding on to. This is gonna allow us to make the rocker mostly in one operation, and then we're just gonna flip it upside down and sand a couple of the tabs off, put that baby right into the car. The first step before we start on the rocker is gonna be to clean the machine out, so that way we don't have dissimilar metals in here, because as a green company, Marzilli Machine recycles all of our swarf that comes off the parts. So our first step is gonna be to break this machine down properly. We're gonna take this vise out, we're gonna clean all the swarf out, and then we're gonna start our setup. So we've programmed this part here in Mastercam. Now what we need to do is we need to build out the tool list that is going to perform this cutting. So you can see how we have our vices in that match the fixture setup that we've actually just finished building in the machine. And now we need to kit these tools up into their tool holders so we can mount them into the machine and start cutting. So our first tool is going to be a 3/4 inch bull end mill with a 1/16 radius. So let's see what we have in stock. This is our ERP system called ProShop, which has allowed us to become a paperless manufacturing company. And so what I'm going to do is I'm going to search to see what we have in stock for an end mill that can suit this purpose.
It must have took you years and years and years to figure out what tools for what. That's got to be the art when it comes to actually machining, isn't it?
There's a lot of artistry that goes into machining. You know, there's a lot of ways that you can skin a cat, as they would say. But yeah, experience tells you what type of end mill you should pick, how many flutes it should have, what kind of a coating it should have. But this is stuff that if you have a good tool manufacturing representative, which ours is Cameron Supply right here.
Shameless plug.
Shameless plug. This guy deserves it. He's been with me for 10 years. He is the bee's knees. He actually comes into our facility and he'll teach us about new cutting techniques and tooling. And so that's a way that you can learn it rather than just through trial and error. And so relationships in this industry are everything. So I'm going to come into this and I'm going to sort. We want to pick a 3/4 inch end mill, and then I'm going to come over to where my radiuses are and I'm going to tell it that I want. And so that's everything that I have in stock that meets that criteria. And so now we're going to take a look and see which one of those will actually suit our purpose for cutting this.
Here's what blows my mind. How did you even know that you wanted a 3/4 for this first pass?
I want to remove as much material as I can. And so having a thick, sturdy end mill that only has 3 flutes so I can make room for the chips to evacuate as we're pulling the chips out. And I also need to have a pretty long length of cut because we want to come from both sides and remove all the material on this control arm. So the larger the diameter of the end mill, the longer it can be and still be rigid enough to take the cut. And so I think I've narrowed it down to this one. It has the right corner radius and the coating that I want. So I'm going to open this tool up and take a look at it.
Oh, that's a picture of it and everything.
Oh yeah, and we know where we order it from, and Cameron Supply right there. Second shameless plug. The EDP number, the cost associated with that end mill, that said that was in bin 622. So we use a special internal tool ordering system in here. And so cabinet 00, draw 600. I'm going to go into 622, and that's the end mill that I want to use. You can see it's got the correct.
Can we show this?
Absolutely.
So this is you call a
End mill. And so this cutter will produce upforcing as as it spins around. It will pull up and pull the chip up and out and away. And that's why we're going to cut the dovetail onto the bottom of the parts, which is our next step. So that way we make it so it cannot pull up and out of our vices no matter how hard we're pulling on it.
dovetail. You mean that's going to have like almost a recess so I can't pull out?
Correct.
Okay.
So what we're going to do is we're going to remove this tool and replace it with this one.
Oh.
We're going to use a new technology called heat shrink. Come on over to my heat shrink machine. All right, so we're going to put the tool into the heat shrink machine. We're going to change our guide so that way it matches, so it's as close to the tool as we can have it. What this does is it contains the heat in here. Push the button, we're going to bring it down, line it up. We want to get it almost on top of the tool holder but not touching it. I'm going to put my UV glove on.
It's interesting.
It gets pretty hot.
Just like, really?
It is, yeah, really. This was from my house. This is the best thing I have found for using this machine. And then we're going to change our settings over here on the screen. Was this a pencil holder or a thick holder? It was a thick one. This has a 3/4 inch tool in it, and then it's going to automatically change everything. Now we inserting the tool or removing it, and then we're going to heat this up. When you can see it getting hot, that's induction coil heating.
So what would you have done if you didn't have this tool?
We would have used some kind of a mechanical process to get it out, but this heat shrink technology is really good. It makes it so that way you can't pull the tool out. It even doesn't want to come out now.
Is this something that common that you do a lot?
Changing the tools out?
Yeah.
Oh yeah, for every job.
So if you weren't going to do this, you'd have to have a whole new chuck?
It depends on what kind of technology you want it to do. Okay. Now, while it's still hot, I actually want to get in here and drop. You can actually see in there, it's cherry red, right? And so we're going to drop our new tool in there. Pull this out of the way, and presto changeo, we're going to cool that down. So what it's doing now is it's blowing air on it so we don't crack it. And as the timer counts down, 4, 3, 2, 1, and now it's going to blast it with coolant and make it so it's cool enough for us to handle. Then it's going to come back and blow all the coolant off one more time.
Wow.
And if you tied that end mill to the back of your truck and tried to pull it out, it would break before you'd get it out.
How many cycles could you do with that piece before you?
200 to 300.
200 to 300 and
Yep.
it's done?
And now I'll be able to touch that with my hand.
Dude, that's so slick.
It's still a little warm. I mean, I could pick it up, but I could run it on another coolant cycle too. Ready to cut?
Oh, yeah, I'm nervous. All
Oh, I'm ready. Let's cut it.
right, let's do it. That is absolutely incredible, man.
All right, now we're gonna take
Killer.
it out of the machine
Boom.
and we're gonna check it. We're gonna see how close we came to the original design.
Oh my goodness, look at this thing. It's so incredible to design it and then see you just whip it up.
Well, what I'm doing right now is I'm just kind of cleaning off a little bit of the coolant, making sure it's nice and dry, and we're gonna spray it down with some foot powder.
Oh, really?
Yeah, well, it's
You mean like-
an industrial version of foot powder, because what we wanna do is we wanna use a new technology that I have here in the company called blue light LED scanning. And so what we're gonna do is take a 3D scan of this part and we're gonna compare it to the model that you gave me when we first started this project. And we're gonna see if there's anywhere we need to remove a little bit of material or if someplace we should make some compensations to leave some more material on. So let me introduce you to Chris. Chris is ready with the foot powder.
Hey.
So this is our Keyence 3D blue light scanning machine. And the purpose of the powder is to make sure that the light, when it comes down and it touches the part, it reflects properly, so that way the machine can actually read it. Sometimes when we machine the parts, they come out so shiny that the light will reflect straight off the part and won't go back to the sensors for it to pick it up and scan it. He's aligning the scan that we took with the machine with the original model you supplied me when we first started, and it's gonna give us a 3D comparison. Close. Just a little bit in here where the radius is where the tool had trouble reaching. But I think in this instance, we'd be better off leaving it the way it is because it looks nice,
Yeah, it looks better.
rather than trying to cut it again and bring it into the print.
As long as the bolt holes, the geometry, the same thing, we are rocking and rolling. We can leave the artistry where it is. We're good to go, boys.
All right, you ready to cut the rest?
Yes. We are gonna put this in a different machine, I suppose? Or are you gonna make something that this goes into?
So we're gonna build a
We have
second
to whittle
op-
this whole thing off.
Well, we're not gonna whittle it off, we're gonna rip it off.
Okay.
But we're gonna mount this down onto a fixture and use the holes that we put in to screw it down to hold it in place, and then we're gonna come in with a much simpler machine than the one we used to make this one to remove this and to deburr it and to make it look pretty.
Now my question to you is, once you put this in a different fixture, you're gonna have to again find X and Y in that machine, then you're gonna upload the top of this pro. So it's gonna be a separate program.
It will be a separate program, but what we did was before we took it out of the machine, we established these 2 points. And so with these 2 points, we could put it into the machine, put pins in these holes, and come in and indicate it in the same way we indicated in the vices. And that's how we'll make it line up. Then we'll take our probe and we'll probe this hole, and it'll come out like we had made it all in one shot.
Oh my goodness, look at this thing. Holy, you guys are killing it. Absolutely incredible. Next up, we'll finish up all the brackets, we'll tie it all in, we'll make it look sexy, and actually make this thing work. And then from there, we're just gonna wait for our Mentor Motorsports parts to come in, and this thing's gonna be fully done in the front, and we can move to the back and change the geometry, but holy God. I wanted to say thank you guys for tuning in, showing all the love, all the support. I'm pushing hard for you all. I'm rocking and rolling and building away, and I really wanted to thank Jamie Marzilli for coming through. I mean, I just met him. It's incredible what this industry will lead you to. People you meet, the friends you make. And I met him and I fell in love with him, and the guy came through and he's super talented. I'm gonna keep on begging him. I want him to be my mentor. But guys, thank you for tuning in. We took another milestone and we chipped it off, and we're gonna keep on pushing. If you like what I'm doing, tune in, subscribe, say hello, say howdy doody, send me an email, send me a thumbs up. Let's keep on rocking and rolling and keep on building the world's first full-time all-wheel drive El Camino. On that note, I'm gonna go take a nap. Toodaloo.